So today we're going to get into a topic called linear equations, and these are equations that come in many forms, many sizes, well, not shapes, but they're equations that are used to essentially just graph a line on a coordinate plane. So the most common type of linear equation or form of linear equation that you'll see is called slope-intercept form, and you'll see why it's called this in a second. So the form is going to be y equals mx plus b, and I'm going to explain what each of these variables are. So actually, let me do b in a different color. I'll do it in red. Okay, so in this equation, y is going to be simply put the y coordinate. M is going to be the slope. So I'm going to go over slope more in depth in a later video, but essentially what it is the rate at which the line you're dealing with on the graph increases or decreases, depending on whether it's positive or negative, or fractional, all that good stuff. And then the x is the x coordinate, and the b is the y intercept. And the y intercept is where the graph or the line crosses the y axis. And you'll see what I mean in a second when we list an example. So using this format, let's make an example in our heads. Let's say y is equal to 2x plus 1, okay? So y equals 2x plus 1, alright? So if we look back to our format here, the slope would be 2 and the y-intercept would be 1. But right now, all we have to do is graph this equation on this coordinate plane. But in order to translate it, how are we going to do that? Well, it's simple. First, I'm going to make a table so that we can better visualize the points that we're going to use and organize it some more. So what you do when you're trying to graph these is you try to find different points that this equation is going to cross or take, right? So to do that, you plug in an x value, and then you evaluate the expression here. And once you evaluate that expression, you're going to see that y equals that expression. So y is going to equal that value that you get once you evaluate this expression, okay? So for example, let's say x were to equal 0. So plugging in 0 to this equation, you would see that 0 times 2 is equal to 0. And then if you add that to 1, let's just write our 0 here. That's our x value. And then you add that to 1, you would get, well, 1, because 0 plus 1 is 1. So let me just write it out here. 2 times 0 plus 1. Y equals 0 plus 1. So y basically just equals 1 in this situation. So our y value for the corresponding x value of 0 is 1. So that's going to be our first point, 0, 1. And this is actually our y-intercept, as I said earlier. The y-intercept is where that line will touch the y-axis, and it is also when the x-coordinate is going to be equal to 0. Because whenever x is equal to 0, you will notice that that is at the y-axis. So that is when the line is crossing the y-axis. So this is our y-intercept. So now let's find some more points. We don't have to write out this equation at all, really, for the smaller numbers. It's very easy to do in your head. So say x were to be equal to 1, then that would be 2 times 1 is 2, plus 1, 3. Easy. You could just keep doing this. So x2, 2 times 2 is 4, plus 1 is 5. So you could keep going. 3, 7, 4, 9. Notice how the y's are increasing by 2 every time, while the x increases by 1, because you're multiplying that x by 2, and then you have that 1 from the start, right? So to graph this, we can just plot these points down. So 1, 3, 2, 5. You only need really 2 points to graph a line, because after you do that, you can just plot your straight line and keep it going in this path, right? But we're just gonna plot some more points so you can see what's going on. So 2, 5, 3, 7, and 4, 9. So now we can just follow along this line. Very simple. And the line will also go into the negative, so remember that. The line just the graph stretches out to all values, and it just keeps on infinitely going, and you can make as many points as you want. So the next form of linear equation that we're going to get into is the standard form. I believe I'll be going over that more in depth in a later video. But standard form is essentially ax plus by equals c, right? And you can start to see that you can really convert a form of linear equation into another form of linear equation. So you could just subtract minus ax on both sides, and you would get by equals c minus ax, and then you could divide by b and then get y equals c over a plus x over, plus a over b x, right? So really, these numbers are going to be the coefficients. Oh, I didn't even know you could do that. But these numbers a and b are going to be the coefficients that you see on the x and y coordinate. But essentially, it's just the same concept. You're plugging in the x value to obtain a corresponding y value, right? So let's make another table here. X and y. And the c is usually going to be a predetermined value that you can add your x value onto, so that you can get your y value. So let's see here. Say we had the equation 4x plus 3y equals 12. Why not? So like I said, it's the same concept. You plug in an x value. Say we have x equals 0, and then you solve. So 3y equals 12. So instead of simply evaluating an expression like we did up here, where we had y equals like 0 plus 1, so y equals 1, what we do here is we solve for y. Instead of straight up having y, we solve for it. So divide by 3 on both sides. And you'll get y equals 4. So the reason why slope-intercept form is usually the most common form of a linear equation that you'll see on this graph is because it's a lot simpler than than doing something like this in standard form, where you have to solve for your y coordinate, where it becomes a whole extra step. There's another form, a much more complex form of linear equation that we'll get into possibly in another video. It's called point slope form, and essentially it's just very complex, so I won't really be going over it in this video. But that's sort of the third type of linear equation that you might be dealing with. So we see here that we get 0, 4 for our first point. So 4 is going to be our y-intercept in this case. 0, 4. Alright. And we can just keep on plugging in these points. When x equals 1. When I have a standard equation, I like to usually convert it to slope-intercept form. But if I didn't, I would just do the solving in my head. So when x equals 1, 4 times 1 is 4. Subtract 4 from both sides, and you would get 3y equals 8. And then divide by 3 on both sides, and you would get 8/3 for the y value. So very weird number. But yeah. So as I said before, you only need 2 points to 2 points to graph a line. So that's what we're gonna do here. 1 8/3, so 2 and 2/3. So it would look like something like that point. And then you would draw a line here. It's not gonna be very straight, but you'll do a better job than me when you're graphing your lines. So the reason why this line is going in the opposite direction is because the slope in this case is negative. Whenever the slope is negative, the line is going to decrease from left to right, or rather we could say the line is going to increase from right to left. When you have a positive slope, the line that you graphed is going to increase from left to right? So yeah, this is basically the foundations of graphing linear equations and linear equations in general. So you have your slope-intercept form, you have your standard form, and you have your point-slope form, which I'll go on about in a later video. Next video, we're gonna get more into specifics about y-intercept and things like how to find slope given 2 points, or maybe how to find the y-intercept given a point and the slope. Also, we're going to get into more of standard form and what these values actually mean, because they're not just meaningless coefficients, and how to get intercepts using calculations that you can do with A, B, and C. So thanks for watching, and I'll see you in the next one.